We're going to look at segment congruence now. So previously we identified that segment measures are reflexive, symmetric, and transitive. Since the segments with the same measure are congruent, then congruent segments also have those properties, reflexive, symmetric, and transitive. So a quick review on that one. The reflexive property of congruence, that one is the one that says that something is congruent to itself. The symmetric property of congruence says that if you've got a line segment AB congruent to line segment CD, then that means that line segment CD is also congruent to line segment AB. And the transitive property says if you have line segment AB congruent to line segment CD, and line segment CD is congruent to line segment EF, then that would mean that line segment AB is congruent to line segment EF. So keeping those in mind, we want to see which property of congruence is being used here. So this would be a good place for a quick pause, and then come back and check yourself. So the first statement says if line segment DE is congruent to line segment GH, then line segment GH is congruent to line segment DE. So this is just taking the two and reversing the order. That is the symmetric property. Okay, the second one says if line segment AB is congruent to line segment RS and line segment RS is congruent to line segment WY, then line segment AB is congruent to line segment WY. So that would be the first one equal to the second one, and the second one equal to the third one. So that way, that means the first one must also equal the third one. That's transitive property of congruence. And the third statement here says line segment RS is congruent to itself, line segment RS. That's your reflexive property. Okay, so on the next page here, we have another guided practice. It's another proof. So you're going to try this one and then come back and watch the video on it. For your convenience, those properties of congruence are also listed at the top of this page.